The next very important topic is to learn what we talk about कि number की type क्या है. So there's 4 main types that you're doing in your O-level exam, but these will serve you in anytime you're doing math, even at higher levels. So the symbol N, and you write it as this stylized sort of big N, is for natural numbers, and these are just whole numbers. Okay, so this is the simplest one, and whole numbers are 1, 2, 3, 4, 5, and so forth. Okay. So you don't even have 0 here. These are natural whole numbers, just the way it sounds. Okay, you started counting, people would say 1, 2, 3, 4, and that's where it first emerged. Then you get to a bigger set outside this, which is Z. So it includes natural numbers, but you add 0 and negative to it as well. So what we do is hum kehte hain, all right, let me extend the number line and add it. So importantly, and you'll get to set notation, but if I'm drawing it, then Z is bigger than N, because clearly natural numbers to aayenge, we've added some stuff to it. We've added 0 and negative. The next bigger subset is Q, which is rational numbers. Now what are rational numbers? These are, you have your whole numbers, you have 0 and 1, but you also add fractions that can be written as recurring decimals. Now this sounds pretty complicated, we'll do this later, but these are nice sounding, sort of half is 0.5, 1 over 4 is 0.25, but 1 over 3 you get 0.3333. This is not a rational number, okay, because it never stops. It just keeps going 0.33333. So that doesn't come in rational numbers. What that comes in is real numbers, R. So this is tricky. लोग confused हो जाते हैं कि यार real numbers तो natural numbers भी तो real हैं, but real, the way we use it in math, means pretty much all of these. So it is natural and the integers 0, negative 1, and the rational numbers which were whole fractions, but also all of the irrational numbers which we can't just represent as a nice fraction. Or isme you'll also start getting symbols like pi. This is a new thing you'll learn. It's very cool. We'll get to it, but this is a number that never ends actually. Patani 1412 something. It keeps going, and you have to approximate it. You can't really express it neatly, and that's the point. I can't really express it as a neat decimal. And under root 2 as well, you get 1.14 something, 1.4 something. You can't really represent it, and under root 51, things like that, right? So root 49 we know is 7. That's nice and neat. So that's rational, but root 51 you can't find. Try it on a calculator. It'll just give you an unending decimal. So how do I represent this? I represent it on the big scale that I was trying to draw. So sabse andar wala set, smallest is natural numbers. Isme it's just positive numbers, 1, 2, whatever, right? The slightly bigger set which is around it is Z, which were integers. So that's here. Isme we've added 0 and we've added negative numbers as well. Then the slightly bigger set than that, which adds to this rational numbers. These are nice whole fractions. And then finally, the biggest set out here is real numbers, which has all of these, but it also has your irrational numbers in there, which are examples pi and under root 2. So the next concept we have to learn is prime numbers, factorization and multiples. Prime numbers kya hote hain? You've seen these before, but these are numbers that can only be divided by themselves and 1. So 2, 3, 5, 7. The next one is 11, then 13, and so forth. These are prime numbers. I think up to 13 is enough to know, but in your book, and I'm sure by now you've learned to use these. 17 bhi hota hai. And what are they used for? So the first application is something called HCF, which is highest common factor. Okay, which has multiple different uses, but let's first do an example of how to find it. So if you're finding the highest common factor of two numbers, 24 and say 16, by the way, you can do it for 3 numbers, for 4 numbers, but let's just do. The first thing you do is you draw this grid like this, and you put 24, 16, okay? Now if there's a third one, you can also add it here. Actually, let me just do that because it's the same process. Let's just put 12 here as well, okay? So these 3 numbers. Now what you're going to do is you're going to use only prime numbers. So only prime go here, prime. You will divide by any number you think that they have a common factor. So let's say we try 2, all right? So one by one we'll divide each number. So 24 divided by 2, and what am I doing? So if I divide this by 2, I'll get 12. And how do I get that? So I divided first this number by 2, I got 1. And then I divided this by 2, I got 2. So get comfortable with this sort of cancellation and doing it. Then if I do the same thing to 16, so 16, I can't divide 1, so I put 0. I carry the 1, and now 8, which should be obvious as well. 8 2s are 16, but I'm just showing you the method. 12 divided by 2 is 0, 1 carry with 12, and it's 6. Okay, so that's the first step. Then you keep doing this till you stop finding common factors. Factors kya hote hain? Numbers that make up a number. So for example, factors of 12 are 2 times 2, which is 4 times 3. That's what we're trying to get to. That 2 times 2 times 3 is 12. So these are the factors of 12. So we're trying to get to that. Like, how do we find these prime factors? And not just that, we're trying to do the highest common factor between these numbers. So let's repeat it. Let's divide by 2 again. Yeah, left side pe you keep count of the factors and you just keep dividing on this side. So let's do it again. Step 2, I divide 12 by 2, I get 6. I divide 8 by 2, I get 4. And I divide, I've made a mistake, haven't I? Because, oh no, this is fine. 6 by 2, I get 3. All right, now we have a problem. Is there a common factor that divides all of these? Usually what you're looking for is koi naya prime to nahi aa gaya, and so this is a prime number. So immediately we can only divide agar sub 3 ke multiple hote. There's no way, like if I try 2, ye to divide ho jayega 3 and we'll get 2, but I won't be able to divide this. So when you're doing HCF, the minute you encounter a situation like this where you've hit a prime number in any one of these, then you have to stop. Okay, and what does stopping mean? Now you just take whatever were the factors that you had got to and you write it like this. 2 times, in this case 2. So you get 4, and the answer is 4 is the HCF of the numbers we started with, 24, 16 and 12. Now intuitively iska kya sense bani? Think about it. 4 will divide all of these numbers. 24 में भी 4 आता है, 4 6 are 24, 16 में भी आता है, 4 4s are 16, and then finally 12 में भी आता है, 4 3s are 12. And there is no higher common factor. 4 से आप बड़ा करोगे, immediately you'll run into some problem either with usually the smallest one. So 12 will no longer be divisible. Okay, so that is HCF. Now what is LCM? LCM is least common multiple. Another important concept, common multiple. Also many uses in math, but right now we're just learning ke karte kaise hain. So let me take the same numbers actually, 24, 16 and 12, and this same grid, but you'll notice there are some steps which are different, and LCM mein hum chalte jate hain. So let me do the steps and you'll notice the difference. You do 2s are, you get 12 just like before. I'm basically just copying this table abhi ke liye. Then we did 2 again. So far common factors, prime numbers, 2 को इससे divide किया 12, 2 6 are 12, 2 4s are 8 and 2 3s are. Now at this step we actually continue going. So we just keep going till we get to 1s. So let me just use 3 for example. So 3 2s are 6. I can't divide this, but I'll just bring it down, and 3 1s are 3. I can divide this, so I'll put a 1 here. Now keep going. Let's do 2 again. I can divide this, 1 aa gaya. I can divide 4 2 aa gaya, or 1 to hai, so it gets carried down. And finally 8 2 reh gaya. Let me do 2 again and I'll get 1 1 1. So what have I achieved? Well, now let me multiply out all of these factors on the left, all of them. So I have 8 2 2 ek aur 2 times 2, and I just write like that. I'll do 3 2 2. So 3 2 2. If I multiply this out, I'll get 2 2s are 4, 4 3s are 12, 3 2s are 24, 24 2s are, and you can do this on a calculator, 48. Now what is so special about 48? Well, it is the least common multiple. What does that mean? All of these numbers that we started with, 24, 16 and 12 can be multiplied by some number to get 48. So 48 is in some way a common multiple of these, and let's test it. So 24 2s are 48. What about 16? 16 4s are 6 4s are 24. 16 4s are, no, this is wrong. 16 times 3, sorry, 6 3s are 18, 3 1s are 3 4, 48, and 12 into 4, 12 4s are 48. And importantly, it is the least LCM क्यों कहते हैं? इससे छोटा कोई number नहीं है which has this property के all three of them can have a multiple that becomes that. So this is LCM. इसमें you keep going, and HCF में you just stop as soon as you can't divide all three. All right.